we did household wiring, and we said that how which this comprises of live, neutral, and earth wires. Earth wire is generally green, live wire is red, and neutral wire is black, or it can be blue also, dark blue. So these are the three wires that run through this. So if you have, let's say, an appliance which is only having two pins, okay, for example, you have a radio or you have just a lamp, right? So for the lamp, you don't need earthing, right? Lamp is there in the ceiling. You're not going to touch the lamp and get a shock, isn't it? So you will connect the, if I draw this, you have the red wire, then you have the neutral wire, blue wire, and you have the earth wire. These are the three wires that are running across your house. And now we have the lamp. I'm just drawing the lamp ulta, okay? Right? And this lamp is, you need to, of course, this lamp is going to be connected to a switch in the plug, right? The plug board, right? But essentially what you're doing is you're connecting this one wire live for it. Hold on. One live wire you're connecting, and then you're connecting the neutral wire. It's like this, okay? When you connect this, then the lamp will start glowing. Here, earth wire is not used for the lamp because the lamp does not use the 3-pin connection, okay? In the 3-pin connection, this particular pin is for the earth, okay? Whereas, if supposing you have an oven or you have a grinder, okay, and the grinder is using this 3-pin connection, okay, then what we will do is, okay, we will connect this within the circuit, within the board. The green wire will be connected to this socket, okay. A red wire will be connected to this, and the blue wire will be connected to this. Are you following this, guys? So the 3-pin plug will be utilizing the earth wire as well. This is live and this is neutral. Okay. And the reason why we want this 3-pin also, we checked. Okay. That is the next concept. That is a concept of earthing. Okay. So why do we need earthing, guys?
So to prevent people from getting shocks.
You from getting shocked, okay? So supposing we have a iron box, okay? And this iron box has got a metallic casing. And someone has not done a proper job in the wiring part, okay? So supposing this is the, what do you call? This is the live, this is the neutral. And let's have this resistance. Basically, iron box means it's just a resistance inside, no? So let that, this be the resistance wire, okay? Resistance coil inside the iron box. And we are supposed to connect the live wire to this, okay? And we are supposed to connect the neutral wire to this. Connection has been made. But then that electrician fellow, no, he has not done the taping properly. And the few strands of the live wire are accidentally touching the metal casing. Because those live wires, they have to be properly taped and you have to secure it. But Hari Barime, what they do, they allow these hairs to touch the body. Okay. And here also is not done properly. Okay. Then what happens is, because of the current that is flowing, even the body, actually current has to flow only through the coil. Okay. current flows through the coil will get red because of I square RT heating loss, heating of the resistance, and that heating is communicated to the bottom plate, and our clothes can be istrified. Okay, that's the thing. But now what is happening? Current is flowing through this coil. Current is also flowing through the body. Okay, this is undesirable. Current is flowing through the body because you have not done proper wiring. Okay, and then accidentally, if our hands touches this, right, then we get a shock because current is now flowing through us and it is going into the earth. We are not wearing this footwear. Okay, so current is through the body. Current is flowing through us, okay, and it is flowing through the earth, then we will experience the shock. Okay, then what is this earthing? Then these what do you call appliances, they will have one metal piece which is connected like this. Okay, this is called a collector. And then what they do, if in case the body has got some current like this, okay, they will trap that current to flow through this green wire. Okay, and then they will take the current will flow in this direction. Okay, so now imagine the casing has got current. Okay, you're touching it. Why doesn't current flow through you, and why does current have to flow through the connector and the collector, and then it goes back to the 3-pin plug? Why does it not flow through you now? Are you following my question?
Yes, sir.
Why should the current not flow through you? Because you're still
Sir,
touching.
because that so basically the wire possesses less resistance as compared to you as a material, right?
Okay. Because we, as a human body, we have resistance. Okay. And what happens to the current is the current is seeing two paths. One path is it can go from the body of the Istri box through this beautiful metal collector, and it can flow through the green wire. Other path is current can go through your hand and reach the earth. Okay. So we can draw it like this for the current. It has two paths to flow. One path is our body, which has sufficient resistance, and the other path is the earth wire, which has low resistance. Okay, so what the current will do, it will say, "Hey, let me flow through this man," because anyway the body is there, body is having higher resistance. Okay, so in that way, we are not going to get the shock, even though we are touching the metal casing, which has current flowing through it. We will not be getting shocked because of this logic. Alex, do you follow this?
Yes.
Okay.
So, a question I had is, why do
Uh,
we only get shocked when we touch ground, but not something else? Like, if we were to wear, let's say, rubber
Rubber chappals, no?
materials, yeah,
Yeah.
and let's say life went through us, but we would not get any shock. Why do we
Why
not
does
get
it
shocked
happen?
like that?
No? Okay, I will tell you that. But this earthing, did you understand?
Yes, sir. I got
This earthing, what is the need for earthing? And it is not given to all appliances. Okay, it is good. It is a good practice to provide earthing everywhere, but they will not give it for example, fan is there, okay, or bulb is there, your table lamp is there, it will only have 2 pin. Okay, there is the casing is not made of metal, you will not get it. Okay, so only for those appliances which have metal body, refrigerator, oven, then iron box, geyser, all these fellows will have the 3-pin connection. Are we good with this, guys? Okay, then next comes this question. Okay, Alex's question: how is electrocution prevented? I answered this question, but you have forgotten. When we use insulated footwear, means instead of telling rubber, I am saying insulated footwear. Okay, so let's assume that there is a live wire. or it could be the end box, it could be a live wire directly. Okay, assume the voltage is not very high and you can safely touch it. Some voltage is there, let's say some 50, it's plus 50 volts. Okay, and what Alex is doing, he is he's trying to hold one end of it. Okay, and he doesn't want him to get shocked. Okay, he's like this. Okay, so in the first case, Alex is not wearing any footwear. Okay, then what happens is, this is the ground. He's standing on the ground. So look at the current. For the current, the path is that it is going to flow through this positive terminal. Alex is providing a path. Okay, and then current can flow through the ground. Means the circuit can get complete. The circuit can get complete. You can imagine like this. This is the live wire. This is Alex. Okay, and he is touching the ground. Okay, so the current can go through Alex, okay, through his feet, and it can go to the ground. The ground is considered as the zero or negative potential. So you are, even though you have resistance, you are closing the circuit. Are you following this, Alex? Whereas if you wear rubber footwear like this, okay, this footwear is made up of insulated material. Okay, then what happens is, it's as if the circuit is open. Means here there is a gap here. Are you following this? It's as if you're not closing the circuit. The circuit is open. Are you getting me?
Yes.
Okay, so when the circuit is open, because it is insulated material, no, the current will not flow through the insulated material and to the ground. There is a break. So you may touch the live wire, but you're not touching, your ground, your feet, which is touching the neutral, which is the ground, okay, is not closing the circuit because you are wearing a well insulated shoe. Okay, that's the reason you will not get a shock. See, for the similar reason, if you have an aeroplane, right, and it is in flight, and it is going through, let's say, stormy area, okay, and there is a lightning strike is happening. Okay, we are inside the aeroplane, why don't we get shocked? Okay, so this lightning strike is happening, but the lightning is flowing through the aeroplane casing. Okay, but where is the closed path for it? Nothing is going to happen. The circuit is not completed. So therefore, nothing will happen to us even if we are in midair and the circuit is closed. Okay, there is another thing called Faraday's cage, which I will not talk to you now. Okay, that is the second effect, but the first effect is that the circuit is not closed. Similarly, if you are having a car and assume that the car is the only way the car is touching the ground is through the rubber tires. Okay, so supposing that there is some current wire which is onto the casing. Okay, so if supposing you are wearing proper rubber shoes, okay, and you touch the car, okay, nothing will happen to you. And if you're inside the car also, nothing will happen. Okay, because when you're sitting inside the car, okay, even if you are touching the door here, nothing will happen because this current is not, it is not, the circuit is not closed for it. Okay, so the body has current, but the tires are insulated, so it is not getting grounded. Okay, so therefore, people who are sitting inside the car will not be having any problem. Okay, but supposing you don't wear chappals, you're standing outside and you're leaning against the car. Okay, then what will happen is the current will flow from the casing of the car, metal body, through you, and it will go through your legs and it will go through the ground. So if you're not wearing the insulated footwear, you who is leaning around and trying to talk to the passengers inside, you will get a shock. Okay, so basically it's all about the circuit being closed. Insulated footwear is as if they are opening the circuit. They are causing a break in the circuit. Switch is open. Current cannot flow. Current cannot flow means you will not experience shock. Do you get that?
Yes, sir.
Alrighty. Okay. So we discussed about earthing, and also we saw how the earth wire is actually taken and put in the concrete. Okay, the actual process of earthing also we discussed in the last class. And we also discussed that when you had current, that current is of two types, we said. One is alternating current, we call that as AC. The other one is direct current, we called it as DC. So if you are having this normal battery, okay, so this is going to provide you direct current. So if you connect this and then you have this bulb, current is always going to flow from one end to the other. It will not change the direction. This is the positive end, this is the negative end. Current will always go through in one direction, unidirectional. And the bulb will glow, okay? Whereas when you, and the graph for that will be like this. If you have the current versus time, or current or voltage also you can keep. Voltage slash current. This is not voltage divided by current, or I will say like that. Voltage or current, if you try to take around the y-axis, you will have a straight line, means constant current unidirectional, okay? Whereas if you connect this bulb to AC source as is available inside your house, okay? AC source means you will put one symbol like this. This is called alternating. The sine wave is there, no? That symbol you will put, okay? So here what will happen is, during the positive cycle, so if you see the graph for this, it will be sinusoidal in nature, means it is going to increase one time, okay? Then it is going to become 0, then it is going to decrease, okay? So you will have both positive and negative voltages, okay? So here, supposing I have voltage or current. First voltage will be 0, then it will increase. It will become a peak. Then voltage will decrease. It will become 0. This is called positive cycle. And then the voltage will become negative.
So when you say the voltage becomes negative, I assume you mean the direction, right? So if the voltage becomes,
yeah, negative means the direction is,
yeah. So the direction is like opposite
I
as
will,
compared to before.
yeah, I'll explain that, what we mean by negative voltage, okay? Positive. So whenever it is positive, this cycle is happening, okay? Then current will flow like this. Or it may, the electrons will just oscillate towards in this direction, okay? But when the negative cycle is happening, then the current will flow in the opposite direction, okay? So the current will now start flowing like this. So it means that in an AC, it is not unidirectional. It is bidirectional current. Current will be flowing through the circuit to and fro. During positive cycle, it will flow in one direction. During the other cycle, the negative cycle, it will flow in the opposite direction. Are you following this, guys?
Yes, sir.
Okay.
Yes.
Yeah. And see, now many people will ask question, right? So supposing I have an AC circuit, right? Then which is positive, which is negative? Supposing I am taking only one live wire, okay? And I am taking the neutral wire. Neutral wire is black, but I will use blue here. Okay, so, and I will construct my circuit. This is positive, this is neutral. And supposing I have my circuit going through lamp, and this is the path, okay? So now supposing I say AC, how is this happening? Okay, is this going to become positive? Is the neutral going, is neutral negative? And in the next cycle, is this become negative? Is this going to become positive? Okay,
Yeah,
if
yeah,
so, how, what is the voltage here? Is the voltage going to change here in this? Then why are we calling live only for this? Why is this? If voltage is going to change for blue also, because blue means we say zero voltage. Red means we say the red wire, we say it is live wire, means the voltage is there only here, the red wire. So will this also carry voltage in the reverse cycle, isn't it? Because here you are telling this cycle is there. So what is happening? Okay, the answer to that is the blue always will be zero. This blue is there, no? This blue always zero. Okay, this red is there, no? Red can be plus 220. Okay, in one cycle, in this cycle, positive cycle, red can become negative 220 in this cycle. So the voltage here is plus 220 first time, minus 220 the next time. But this fellow is always saying a zero. Are you following this?
yes.
Okay.
So,
That means the live wire changes the voltage from plus 220 to minus 220 volts. Okay, in a cyclic fashion, because it changes in India, it changes 50 times in 1 second, isn't it?
so
50 times in 1 second. Okay, so in 1 second this becomes plus 220 minus 220 plus 220
so
minus. Hold
so
on.
each time it changes, it's one full cycle, right?
Yeah, each time if it is plus 220, it is this cycle. Okay, when it becomes minus 220, it is this cycle.
Okay.
Okay, so it is the voltage which is changing happens only in the live wire. This fellow is always zero. That's why it's called neutral. Neutral is zero. Okay, but just look at it. What happens when the red one is carrying minus 220 voltage? Okay, so now in one cycle I have the live wire. Okay, and I have the blue wire. Blue wire I'm saying is neutral. Neutral is always zero. Okay, this fellow now has become minus 220, minus 220 volts. That means with respect to minus 220, this zero is positive, no? Are you following this?
Yes, sir.
So during the negative cycle, that is when the live wire is carrying a voltage of negative 220, it is as if the blue wire has become positive. This is positive with respect to the live wire. Okay, that is why we put this positive here. Positive doesn't mean it is carrying positive voltage. Is that some positive voltage is given. It is always staying zero only. Okay, but with respect to the minus 220, this becomes negative, this becomes positive. Okay, then again you will have the next cycle where the live wire is once again going to be given plus. Okay, then this becomes plus 220, this remains zero. So with respect to this fellow once again will be negative. Are you following this, guys?
Yes, sir.
Okay, so yeah, go ahead, ask. Okay, and what happens is here, now another question people will ask is, sir, you are telling this is increasing and decreasing. Will the current also be constant? Like in DC, we had a constant current. Let's say some zero 0.5 ampere is flowing. Okay, if voltage is increasing and decreasing, current also will increase and decrease, right? The answer is true. Yes, the current is also increasing and decreasing. Therefore, even we are drawing current also, it will increase, reach a value, decrease, increase, decrease. It's not a constant current here when you are using AC. Are you following this? Okay. And the bulb, no, at these points, there is zero voltage. That means the bulb will not glow, right? But when you will argue saying that, yeah, I put on the lamp, the bulb is glowing only, no? Where is it flickering?
Yeah.
Why don't you see the bulbs flicker?
So, because it's 50 times per second. Like,
Yes, because it is
it's
50
too
times
fast.
per second, you are not able to make out because it's flickering very fast. 50 times, your eyes cannot make it out. Okay, this is more than enough knowledge for you, but for all the curious Joes here who have a lot of questions, I am throwing in this additional piece of information. If you are understanding, well and good. If not, you have a whole chapter, huge chapter, which will take you around 15 days. If I were to teach you, I'll teach that chapter for you 15 to 20 days, called AC current in your grade 12. There you will have what is called rectification, RMS voltage, RMS, because when you say it is increasing, decreasing, how will you say 220, sir? 220 means it's like constant voltage, right? So RMS means root mean squared. Okay, so the actual voltage will go up till 300, 330, but when you kind of average it out, it is as if you are getting a constant voltage of 220. How we do that and all is, for us for a later, it is not possible for us to learn that now. But when we say I'm having an AC current of 220, it is the root mean squared value of voltage that we are telling. Similarly, current also will change in this fashion. There also we are using the root mean squared value of current. So if you are using this I square RT in the context of an AC current, so this I which you are using is the RMS value, root mean square value of the current. And you can do all the calculations you want. You can use V is equal to IR, okay? But it's just that this V is VRMS, this I is IRMS. Just hear it, no need for you to work on that. It's just an FYI. Are you able to understand this, guys?
So,
All right. So these were some of the things that we discussed. And see, there is one thing called fuse. Okay. You would have seen that you have to have fuse. Okay. Where is fuse connected? Okay. They will ask question. Fuse is connected to which one? Is it connected to live wire? What do you call neutral wire or earth wire? Where do you think it is connected?
so I think live wire.
Always. Okay. Whenever you say fuse, the fuse is always connected to the live wire. Okay. So what happens is, what is the purpose of fuse? Tell me.
So the purpose of the fuse is
To
to
stop if
prevent.
there's excess flow of current.
Very good. Tell me.
So it breaks the connection if there's excess or very high flow of current.
Very good. Correct. Okay. So I will answer your question. See, when you are having an appliance, let's say you are having a very expensive TV. Okay. You are having a nice Sony LED LCD TV, which costs upwards of 1 lakh. Okay. And this TV has a specification. So this manufacturer will tell, Bhaiya, you have to give me 0.5 ampere and so much voltage, right? Very specifically, he will give all the details. Okay. In the normal time, your voltage current that is flowing also will be proper. But suddenly, sometimes what happens in the distribution is no fault of yours. In your distribution means in BESCOM fellows, there will be a surge, voltage surge will be there. It is like a fault. Okay. So suddenly you will have high voltage and you will have high current that is available in your circuit. Okay. So many places the electrical safety devices are put. Okay. So in the beginning itself, you may trap it. Okay. Or you will have it within your room. Within your room, you will have circuit breakers which are placed. Okay. You can detect it in many places. Tuck tuck karke it will trip, sometimes in the room, sometimes outside, wherever it is detected. So what happens is, in this fire, if suddenly there is a surge, more current is flowing. That is what is called surge. Okay. But what happens in the fuse is made up of a certain thin wire. Okay. Thin wire, and it can it can carry only certain current. For example, it can carry only 0.5 amp current because it is dimension and it is selected such that it can carry this much. So what happens if it is 0.6 amp? Okay, we know that when current passes through wires, it causes heating. I square R heating happens. Okay, so within a very short period, because the current has become more, this wire will heat and melt. So the wire material is perfectly designed. So it will be solid until it is 0.5 amps. Okay, it may be red or whatever. It is solid. But the minute it becomes 0.6, 0.7 amp, this wire will heat up so much that it will melt and it will break. So once this breaks here, then it is as if the circuit is open. Okay, and your device is prevented from high current. Okay, so the need for fuse is to safeguard. Why do we use fuse? It is to safeguard the electrical appliances from damage. Okay, because even not only TV, even your motor and all can get damaged if large current surges are happening inside the house. Are you guys following this? Okay, sometimes they will ask, I have seen questions, they will give you a circuit. They will say, this is the circuit here, and you need to provide a fuse for this. Okay, what should be the fuse rating? Okay, they will give you some ohms. This is like a fan. This is like some bulb. This is something else. Okay, and they will say this is voltage is something 20 volts pakdo, or you can put 220, whatever, 20 volts. Okay, so this is the circuit, and what should be the fuse that is provided. How will you calculate? Tell me. Means when you say what is the fuse rating, means you have to tell how much current should fuse carry. Should the fuse be designed to carry? How will you calculate?
So we can use
So
Ohm's law, V is equal
right.
to IR, find resistance and
Correct. Okay. So imagine the fuse is not there. Okay. Imagine the fuse is not there, and say, yeah, if this is the circuit, then obviously some amount of current is flowing through the circuit. Okay. The normal scenario when current surge is not there. Okay. So you can calculate this I by using you do effective resistance. All these three fellows are in series. You find out R effective, voltage is given, so you can say what is the safe current. Safe current is nothing but V is equal to IR, I is equal to V by R. You calculate, you will get some value. Okay, then you say the rating of the fuse is such that it should match the safe current. Okay, so if there is supposing this is like 0.6 amp. Okay, so you will say the rating of the fuse should be 0.6 amperes, such that if you get a more current, then the fuse will melt. The fuse will always be working properly until its rated current is reached. If you are exceeding, the circuit is exceeding the rated current, the fuse will burn. Okay, and the circuit will get closed. Okay, are you following this, guys? Current should be fused to designed to carry. If I greater than the rated current is passed, okay, then fuse will burn. Fuse will burn and circuit becomes open. Any other questions you have, guys? In fact, I think that ends the topic. Okay, see, for ICSE students, they need circuit breakers. Okay, some design of circuit breakers, how would mechanism. For you, it's not there. Only fuse, even fuse is not there in your syllabus, looks like. But anyway, I have told you. Okay. So now what do we do? If you go to Guru, guys, each of you access your Guru class. Same current flows through all bulbs. Okay. If any bulb becomes faulty, all bulbs fail. Means they will not work. Then you go for parallel. So here in parallel, no, just 1 minute, guys, please listen to me. See, this bulb may be a 40-watt bulb. Okay. This bulb may be 60-watt bulb. This bulb may be 30-watt bulb. Okay. So based on the resistance, some current may go through this limb. That's what we saw, no? Whenever we were telling parallel connection, I1, I2, I3. You can have different amounts of currents that can go through each limb. Okay. So based on this, I1 can go through this, I2 can go through this, and so on and so forth. Okay. If they are all the same resistance, then obviously the current flowing through each limb will be the same. Okay, but there is no compulsion. Whereas in series, no, whatever may be the wattage for them, okay, irrespective of their wattage, the current that is flowing through them will be same, irrespective of the wattage. So I am noting down here parallel different currents within brackets based on bulb rating, I will say. Shreyas, you're supposed to note this down. Huh?
Yeah,
I want not screenshots. I want you to actually take it down.
yeah.
Nice notes you have to make, the way I taught you. Different currents based on bulb rating flows through each limb. So there is no compulsion that same amount of current has to flow through. Okay. And second thing is, if there is a fault in one area, okay, like here, there is a fault out here, okay, one area, it does not impact other areas in the circuit, areas or appliances. Okay. And one note you put, all domestic wiring even commercial, industrial, all wiring is parallel connection. Not only we want one fan not working to impact the light, AC and other things, each of those appliances, a fan needs only less amount of current, whereas a heater connected to your room requires more amount of current, isn't it? So the circuits for each of those appliances have to be different. For AC, you will have to use thick wire. Maybe 2 amps, 3 amps current will flow. For a fan only, maybe 1 amp or 0.7 amp will flow. So the wiring also will be different for them. That can be accomplished only in parallel connection. Are you guys okay with this?